Hey guys, welcome back to the CTC5 Color TV Restoration Project. I am down to the last board, the chroma board. And yeah, in spite of my hesitating in the end, I did remove all the boards except for the IF board. And honestly, it's really not all that difficult once you get the hang of it. This board is the most annoying though, in that they have 6 components mounted underneath. This is also the board that they tinkered with the most. As one of you mentioned, the later CTC5, the Deluxe, the Super, I forget, there's sort of 2 distinct generations of this chassis. This board is completely different looking. And even this board is different from what they show in the RCA service info. In particular right here, they show 2 10 microfarad electrolytic capacitors, a dual, with 1 negative and 2 positive, and I ordered up a couple Sprague atoms to replace it with, going off the RCA parts locator and parts list. But then when I actually looked at this, I'm like, wait a minute, this doesn't have 10 microfarad caps. It has a ceramic cap, which I believe is a dual 0.01, and that's what Sam shows. So at some point between the A, B, C, D revisions of this chassis, they went from a dual 10 microfarad to a dual 0.01 microfarad. Which is fine by me. I'll just leave it alone. It's probably, the ceramic caps are generally just fine. The only downside for me is that I did order 2 somewhat expensive caps that I no longer need for this project. We're going to take a break from that, and we're going to check out some tubes. I'm curious, as I've been going through this board, through these boards, to see how the tubes check, because they are 100% RCA branded tubes, with almost all of them having 1956 date codes, meaning they are the original, like this 6DE6 IF tube, and it is 6-13, 1956, 13th week. So what I'm curious about is, how many of these are still good? I mean, yes, RCA made fine tubes and all that, but the set was used enough that they replaced the picture tube, and it had some repairs done to it. And a few of the tubes have been replaced. But can all of these remaining tubes, or all the original tubes, still be that good? Now, the other thing is, tubes, they can last a long time, especially if they're not driven really hard, like most of these aren't. So one of my later sets that have a tube you may have heard of is somewhat infamous, the 6GH8, which tend to fail a lot. This uses more mainstream tubes. Well, I mean, for the era that are known to be reliable. A couple 12AT7, 6AW8, 6AN8, 6CB6, 6DE6. Well established, long-lasting tubes. So let's see. Now, something else I was asked about is cleaning them and retaining the ink. So here's the thing. There's printing, and then there's printing on tubes. So some of this, in particular the designator for what type of tube it is, are etched in the glass. So 6AQ5A USA, that's etched in the glass. I can touch it. It's not coming off. If I use a little bit of Windex or something, it might make it a little bit less visible, but it's not going to take it off. The branding, you barely see it left. This is RCA in red. These have RCA in white. Date code. That comes off extremely easily. 6BE6, 6DE6, the designator, again, etched. This, okay, so yeah, if you want to clean it, you could just do that, gets most of it off, take a little bit of, spray some Windex into a paper towel, go over the top, you can clean it off and retain the lettering. Honestly, I don't think it's that big a deal. These tubes are not rare. RCA made millions of tubes. It comes off so easily. Sorry if I bother anybody by doing this, but here's the reality. It just comes off that easily. Forget about aggressive cleaning or anything. Just when you pull the tube out of the socket, you're very likely going to remove it or damage it. So, do what you want. all these tubes are, just about all these tubes are under shields. You're going to have a hard time getting the tube out, testing it, putting it back without smudging those RCA logos. I don't think it's a big deal. And that's typically these tubes. Only a few companies made tubes. Solania, Tungsol, RCA, I think GE. And if you see it branded with one of the lesser known brands, Silvertone or Muntz or something, it was printed on like that after they were mass produced, and that they all used ink that smudges. It's been my experience, so I wouldn't get too hung up on it. Well, let's start out with the 6DE6s. So there's 2 of them in the IF chain. Typically, when I test IF tubes, they tend to have a lot of secondary emission and be kind of worn out. So let's see how these go. My scrolling thing does not work that well, so I don't know if I can get the 6DE6 on this before it seizes up. I tried opening this up and doing something about it, but it's just, I just need to replace the whole roll. Yeah, I get to about 6BW8 and then it's game over. So luckily this came with my tube tester, which has all the common tubes listed in it. So 6D6, but this is slowly starting to fall apart. So I gotta do something eventually. 6DE6. JR35627. JR35627. 1184. 1184. Here we go. First tube being tested. Now, the one that I've visibly seen that it's obviously shot is the damper tube. Some of the tubes, like the 3A3 high voltage rectifier, the 6BK4 shunt regulator, I can't really accurately test in a tube tester like this because I can't put anywhere near the normal operating conditions. But those are also common tubes, so I'm inclined to just put new old stock tubes, and in particular the shunt regulator, that's the early type that has no type of shielding or protection. I'll put in a 6BK4C or a 6EL4 later tubes that are more robust and have shielding. Alright, some of you more observant viewers may have noticed I had this at 12.6 for the filament voltage to 6.3, so I did roast the tube a little bit, but these tubes are pretty hardy and it tests just fine. Let's pop the other 6DE6 in there and see how that goes. Let's go and we'll start popping all these guys out of the chroma board. If I had to wager, I'm going to speculate that all the tubes are going to be good or a little weak, and none of them are going to be shot except for that damper tube. It's obviously gone to air. It's fine. According to my tester, which I trust pretty well. Alright, 6CB6. So I will continue and let you know if I find anything of interest. Okay, now this is bizarre. I want to test the horizontal output tube, 6CB5, 6CB5A to be specific. My tube chart says it has a filament voltage of 7.5 volts, as does the printout inside the lid. However, the schematic shows it is running at 6.3 volts in parallel with all the other tubes, which makes sense. That's why it has a 6 in the tube number. So let's see, what does a tube manual say? Now they may have a reason for when you're testing it to push it harder, but that's a first for me. So could it be a mistake? Seems a little unlikely. The very mainstream tube tester. 6CB5. RCA tube manual 6CB5. 6.3 volts, 2.5 amps. Maybe that's why they said to put this at 7.5. That's a hefty filament current. Maybe on 6.3 it drags it down so much it can't. You're not going to get to 6.3. So let's set it up and keep it at 6.3 and see how it goes. JR4023. I suspect that's what it is that this thing can't supply enough current, so you got to go up a range. And that's plate cap. In fact, the little fuse bulb over here is glowing ever so slightly. Let's let you line adjust. We're a little low, but we can get up there. I can't easily measure the filament pins on this tube, but it's a little odd. That's great. I'll put it at 7.5. Just that's what they say to do. It tested so good with 6.3, now I expect it's going to be even higher, maybe off the end, and that's exactly what it is. So I'm not sure why they tell you to go to 7.5, but anyways, the tester says it's good. Bit of discoloration on the getter, but that doesn't necessarily mean anything. And this is one of the tubes that I don't think is original. The construction looks a little bit newer, also a little bit sloppy. Two bases on there are a little bit crooked. I don't know enough about tube lore to tell from the graphics. There's no date code on this. And the lack of date code is one of the things that makes me think it's not an original, because the other ones that are original have a date stamped on them. And I've heard it's something to do with the color too. Like the tubes that have white printing might be originals and the reds are replacements. So here's a red. And no date code. Here's a red, a date code. Another red, also no date code. CB6 white, that has a date code, 9th week of 69. Just try to dig up some more tubes. There's a few more red, no date code. Red, no date code. And yellow, that has a date code, 22nd week of 56. So maybe more of these have been replaced than I realize. Or than I was hoping at first. But so far, no bad tubes. As I say, a lot of these tubes are shielded, and sometimes when you take the shield off, the tube comes right with it, and they're stuck in there pretty well. A little tip to get them out. Just be careful, but take a hex driver, put it over the top of the tube, and push. 6EA8 in USA. No date, red printing. White printing. 1956. 68. Alright, so going by the white printing being the original, I'd say only about a quarter of the tubes are originals. 6AU6, 1956. Alright, I am getting some weak tubes. The 6CB6, which is an original, was into the question mark region. This is 6AW8, also an original, and it's definitely in the replace zone. Doesn't mean it couldn't work, doesn't mean you can't produce an image. It's just below the threshold, according to this tester, with these settings for what a good tube should test like. Here's another 6 AW8. This is a replacement, I do believe. You can run tubes into the ground. I've said tubes with barely any emissions and the set will still work. Especially when we're feeding in a really strong signal. The tube has diminished gain, say in an IF tube, and you're feeding in a really strong, clean signal. It's not as critical. Replacement's good. 2-section tube, so we should check the other side. 2301. 1578. And that's good. So definitely some of these originals are not testing so hot. Alright, just wrapped up testing all the tubes. Got a 6EA8 in there right now, and it is deep into the replace. So here's the final tally. All these tubes are bad or weak. And out of these, 1, 2, 3, 4, 5, 6 out of the 7 are originals, including the 2 tubes in the tuner. All weak. And then, of course, there's the damper tube, which has gone to air and completely shot. But that, going by the theory that the red means a replacement, this is not an original tube, but that is dead. These are all really common tubes. I have plenty of new old stock, so these will all get replaced. The rest will go back in the set. So I just finished reworking the chroma board. I still have a little bit of rewiring to do to reattach that board. I did replace the paper caps underneath the chassis and some of the critical resistors like around the shunt regulator and a horizontal output tube and a few caps up in here. Then I got to all this. I'd heard the Convergence on this set was a bit of a challenge, and I can see why. I can see why. I've also read through the instructions. So what's Convergence? Well, there are 3 electron guns in the color picture tube, red, green, and blue, arranged in a triangle, and they're shooting towards the screen, which has a bunch of red, green, and blue phosphor dots on it. Those electron beams need to be aligned such that the green beam only hits the green dots, and the red beam only hits the red dots, and the blue beam only hits the blue dots. How do they make that happen? Well, there's something called an aperture grill, which is a sheet of metal with a bunch of small holes in it. And the idea being with you need to control the deflection and the angle and get everything just right so that as the red is scanning across, it only hits the red holes and gets through to the screen. So how do you make all that happen? Well, it's around CRT, so we do have symmetry helping us to some extent, but it's still a rather tricky thing to do. Now, later sets you may have seen a Convergence panel. It's a board, sometimes on a long cable you can actually detach so you can see the front of the set while you're manipulating them, and there's a bunch of controls on there, and you tweak those and follow the directions, and you should get a good color image. A little bit more difficult in this set. One, the picture tube is a 12AXP22, which is a metal cone. See, your enemy your enemy and your friend with this is magnetic fields. Good magnetic fields are coming from the deflection yoke and associated circuitry that move the beam how you want it to. The bad ones are the Earth's magnetic field and any stray magnetism that's around. So you may have heard of degaussing. Well, that's a way to disrupt or eliminate any magnetism that might have gotten on that aperture grill, that sheet of metal I mentioned with the holes in it, that can get magnetized. Well, in our case, the entire CRT cone can become magnetized or have spots of magnetism on it. How would that happen? Well, somebody walks by with a magnet, of course, that could get magnetized, but the Earth's magnetic field comes into play too. So, we'll get to it when we get back up to the cabinet, but there are things called neutralizing magnets. There's 6 magnets around the picture tube set into pockets that you need to retract or extend and manipulate for various steps. And then we have all of these. This is daunting, I gotta say. Not just to make the adjustments, but to hope all these controls are still good. So we got these coils, and some of them are at a bit of an angle. That's so that they line up with holes in the front. See, we've got all these cryptic symbols on here. Those have to do with the red, the green, the blue gun. See, we got noise, tilt, amp. We need to adjust all this stuff. And it's not just the coils. It's not just these shafts sticking out. There are also ones that you have to use a slotted tool to get in there, and they are dual controls. Dual control, dual control, dual control, dual control, dual control. So across all this, what do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's just round it up and say we have 20 potentiometers plus half a dozen or more adjustable coils. All of those need to be adjusted. And that's in addition to these static conversions, which are permanent magnets around the neck of the CRT in various strategic places. We're going to need to adjust all that stuff. That's in addition to the alignment of all these transformers up top. Another thing kind of playing in our favor, I think, is here's the video audio board. It's rather simplistic. Video audio IF, I should say. And then here's the audio board with a ratio detector and an IF transformer. That's very straightforward. Then there's the chroma board. And I was surprised. I was looking through the alignment instructions for this, and they don't really have any. Well, not like what I was expecting. So if you look at the alignment instructions for the IF board or the tuner, you use your sweep RF generator and markers and look at it on a scope or XY display and adjust it. But for this, it's more like you do a color bar test pattern and hook up a VTVM for some steps, or just look at what's on the screen and do various things with contrast setting and other stuff and adjust these. So not quite as you need to do with the set operating is what I'm getting at. Whereas this alignment you can do up in the workbench without the picture tube being attached. Okay, so what are we going to do next? Well, aside from finishing up some wiring and replacing or testing some of the electrolytics, I'd really like to power this up, do a smoke test on the workbench before we put it back in the chassis and hook up the picture tube. So how can we do that? Well, if we look at the alignment instructions, they tell you how to disable the high voltage. Basically, you pull the horizontal output tube out, but that's not enough because all this circuitry draws a lot of power. And if you disconnect all of it, you're removing a lot of load from the power supply, and your voltages are going to be higher than they should be. So again, in the alignment instructions, they indicate to add a dummy load. I believe it's a 3.5K 100 watt power resistor you attach at a certain point to simulate this and pull down the power supply. So that's what I want to try doing. And I'll hook up the tuner and hook up a speaker and see if can we get audio out of it. Of course we can't, and well, I could put a scope on the output of the video amp, I suppose, and see if a video signal's getting through. Alignment and stuff, I'll wait for that. I want to get this. No point in doing that if we can't get an image on the CRT. So finish wiring, do a controlled power up down here. If things look right, the voltages look okay, we get a little crackle out of the speaker. Then we're going to go upstairs with this, put it back in the cabinet, hook up the picture tube and the yoke and the speaker and whatnot, and go for a full power up. Now, something else I want to do when I do that is use my PR57. This thing draws a lot of power. This can do up to 4 amps intermittent. 0 to 3 amps continuous, 3 to 4 intermittent. So we're going to be pushing this a bit hard, but I do want it, at least for initial power-ups, to have the protection of this, where we can monitor how much current it's drawing, and it has a fuse and a circuit breaker built into it. And this is also well fused, by the way, too. So we've got a fuse in B+ here. This, I do believe, there's somewhere down here, there should be a fuse for the filaments that's just a wire. It's not encapsulated in a glass cylinder like a fuse you're used to. It's just a piece of wire that will burn open. There's excessive current draw. We've got 2 fuses here, and I think there is a fuse on for the flyback somewhere else. Which, by the way, I did recap that. Those power resistors seem to be okay, so I think we're done with that. We're getting close. We're getting close. Well, I tried reforming a couple of the electrolytics, and one down here, this guy up here, no luck. Tried for about 45 minutes on each cap. Leakage current dropped a little bit, but then just leveled out at way higher than I'd like it to be. So before we power this up, I'm going to replace all the electrolytics. Decided I'm going to do it down below, leave the originals up top, mount a terminal strip here and there if I need to, and dig up replacements for the tubes that were bad, and then we'll power it up. Going to do all that in the next installment. Thanks for watching.